So from that video, you can see that there is evidence that facilitators can project their own ideas onto the person who they're supposed to be facilitating, and misrepresenting the thoughts and motives and things of the person that they're facilitating for. You can imagine why it would be really important to answer this question experimentally rather than logically or just using our guts or our intuition, right? This kind of treatments like this, other kinds of treatments that are out there that are, purported to work and things like that for depression or anxiety or other kinds of things, we need to make sure that we're testing them experimentally to make sure that confounds have been controlled and that the best explanation is actually the independent variable, that actually the treatment is the reason why we are seeing differences in performance, not some other explanation. Oops. All right. So I think I might have, yeah. Okay. So now let's use this, what you just watched. Facilitated communication allows people with autism to communicate. And by the way, they've used facilitated communication for people who have had brain injuries and are in vegetative states and other kinds of things. So it's not just autism, but I'm going to use this as our hypothesis. So if the independent variable is responsible, we would say that the support that is provided by the facilitator allows the person with autism to express their ideas, right? Look, it works. It is in fact our independent variable that is causing the change in this behavior, in this case, being able to express their own ideas. If the extraneous variable is responsible, then we've got, the facilitator controlling movements and they're expressing their own ideas. So we need to eliminate that extraneous variable if we're going to be able to make an argument that our treatment is working. And that's the important thing. And so a lot of times when I have students in Psych 309 or Psych 209 who want to be therapists or counselors, and they're like, well, I don't want to do research, so why am I forced to sit through this class? It's really super important for all of us, scientists, practitioners of any sort, that we really understand the difference between something that maybe looks like it should be helpful, and so we just want to try it, versus something that seems like it might have not been developed through experimental procedures, right? Like we can't eliminate the possibility that some extraneous variable is to blame for this outcome. So we have to do controlled research to determine whether the extraneous variable can be eliminated and we still have the effect, right? So how do we end up with confounds, right? If our groups aren't equal before the experiment starts, right? If we were not able to randomly assign them, or our randomization, we didn't have a large enough sample, and so our randomization didn't really work. If our groups aren't equal, they already have differences when the study starts, we could end up with a confounded experiment. What can we do to control extraneous variables? Well, we want to first off realize that the experimenter must exercise control over everything that they can possibly control, so that the only things that vary between the experimental group and the control group is that treatment variable. Like that's the only thing that should differ. So we've got to have control. We want to make sure that our results are meaningful and clear. So we want to exercise that control to make sure that, the findings that we have are meaningful ones, clear ones, not ones that are easily criticized as being due to some extraneous factor. So how do we do that? Well, some basic control techniques. I am going to just keep beating that randomization drum, right? If we make sure that every participant has an equal chance of being assigned to any group, we really reduce the likelihood that those groups are fundamentally different at the beginning. So we've already talked about how to accomplish randomization. Elimination is another way to gain control, and that's where we identify those confounding variables and completely remove them. So, for example, if a noise outside the lab might distract participants, make sure it is quiet for all conditions, right? So maybe put signs up in the hallway or something to make sure that no noise ever happens during any time that you're ever collecting data. Constancy. A confounding variable is reduced to a single value that is experienced by all participants. So this one, sometimes students react to kind of negatively, but this is how you do it. So for example, if men react to a stimulus very differently than women do, you only include one of those sexes in the study. I've had students say, isn't that discriminatory? No, not everybody has, it's not like we're depriving them of, a job or something. We're just saying, for this study, we want just men or we want just women. I've actually done research where I've done just women, in part because women tend to respond to the mood induction more with a bigger change of moods. And so we said, well, then let's just study women. We were trying out a new type of mood to induce. Typically, the mood inductions are to make people either a little depressed. It's not a major depression. It's just a little sad, or elated, which is the term for, being happy. And we were trying to see if we could induce people to feel defensive. And since women in general tend to induce into moods, bigger is the word I'm thinking of, like they have a bigger change. And we were trying something new. We said, well, let's just use women and eliminate sex as a confound, right? Let's just be constant. If you think older and younger people are going to react significantly differently from each other, eliminate one of those age groups, especially if you're doing research in a new area and you really don't know what the pattern should be, and you're worried that the two ages might cancel each other out or something. Just study one group. That's how you can control things, is to get rid of the one that might interfere. Balancing. So this would be to achieve group equality by distributing confounding variables equally across all groups. So if there is a confounding variable, you want to make sure that everybody who's in the study experiences that confound, and that way it kind of effectively eliminates that, right? It's been balanced out. So for example, if you can't get rid of the noise outside of the lab, you get a friend or one of your grad students or somebody to be out in the hallway always making noise, so that all groups have that experience, right? You balance it out so that you can't say, well, there was noise when the control condition was run and there wasn't noise when the experimental condition. Nope, there was noise for everybody. We made sure. So balancing, and then counterbalancing would be especially for within subjects designs. Counterbalancing is reserved for those within subjects or repeated measure designs. So we're going to control order effects by presenting different treatment sequences. And there's lots of different ways to do it. The most cumbersome way is to make sure that each participant experiences all possible orders. Now, in my jelly bean example, where you got a Tabasco flavored jelly bean, and then you also got a cherry, it would be completely possible to do all possible orders, right? So each participant gets to taste a Tabasco first, then they taste the cherry, then they taste a Tabasco, so that they're getting the order effects. With only 2 flavors, that would work. But all you have to do is go like one more condition, like have 3. So now we've got Tabasco, cherry, and something else that's red. Can't think of anything else that would be red that's not a fruit, or cinnamon. Can't think of anything that would be red and not a fruit or cinnamon. So, okay, I'll say watermelon. I don't know. Add in a 3rd condition, and all of a sudden the counterbalancing gets a lot more complex, because you have to have all possible orders. So you'd have to go Tabasco, cherry, watermelon, Tabasco, watermelon, Tabasco, cherry. Okay, so I went through one order, but now I need to make sure that I go watermelon, cherry, Tabasco, watermelon, right? Like they all have to be in all the different orders. With just 3, we suddenly go from what would have been just 3 orders when you have 2 flavors, add a 3rd flavor, and suddenly I think there's 9 orders. Or is it 18? Yeah, I'm not sure. I'm not doing my math in my head very well. There are more orders, like logarithmically, for each different condition that you add. So it can get really cumbersome. So what a lot of people will do in that case, when you have 3 or more conditions, is you have all the possible orders laid out, and then each participant experiences just a random sample of the orders, like maybe 2 of the different random samples, so that across all your participants, the different orders are represented, but within a particular individual, you give them just a subsample. So there are lots of things that we can do to try and take control of those confounding variables and prevent them from interfering with our studies. There's no reason why we should have to be wondering whether some kind of confound is present. I'm going to tie this back to the value of peer review and public feedback on our research. Because a lot of times the researcher themselves doesn't really notice the confound that was present. Somebody else reads their study or hears their talk at a conference and says, "Did you think about this as a possible confound?" And they go, "Oh no, I didn't even think of that." So a lot of times the public verifiability component is what allows us to recognize that a confound might have been present, and then maybe the same researcher will try it again, with that control in mind, or somebody else might try it. Well, what if I control that variable? Will I get the same outcome? So this is how science grows, right? Is by, allowing other people to see what we've done, comment on it, and maybe try it themselves. And so these, I just want to end with that: keep it simple, stupid. Occam's razor principle of parsimony. A lot of times people, when they're thinking about doing research, they think, well, I don't want to be caught out with some, extraneous variable that's threatening the, validity of my study. So I'm going to try and think of everything and control everything and put everything in there. And I'm going to have, and it's impossible. I mean, it really is. And so instead, what we should focus on is designing our studies as well as we possibly can, controlling all the things that we can think of, and then share that information so that other people can give us feedback, so that we can improve it in the future. Also, I'd like to throw out, before you collect data, that's the beauty of having, peers and colleagues and stuff to talk about these things with, because a lot of times just by talking about your design, you get ideas for things that you could tighten up. So that concludes my little dissertation on attempting to control everything and trying to keep your studies as simple as possible while answering your basic questions. All right, I will see you in the next chapter.